You ever stop and think about the irony? You've got these tech billionaires, right? People like Elon Musk, pushing us all toward a sustainable future with Tesla, while also launching these enormous fossil fuel-powered rockets. Or Jeff Bezos, who's pledging billions to fight climate change, while his company is building one of the biggest rockets in history. It feels like a contradiction, doesn't it? Okay, let's really dig in and see what the science has to say about all this.
Look, the new space race is on, and it's happening fast. It's driven by private companies. We're putting more satellites up than ever. Launches are happening all the time. So the question we're tackling today is a big one. As we blast off into this new era, what's the real price our atmosphere is paying for it all?
And this, right here, really gets to the heart of the paradox. On one side, you have these champions of a greener Earth. And on the other, you have these same people running companies that burn massive amounts of fuel to literally punch a hole through our sky. It's this exact tension that makes you wonder, what's really going on with rocket pollution?
Now, if you're only looking at carbon dioxide, the usual suspect, the story seems almost boring. The total CO2 from every single rocket launch in a year is this tiny, almost unmeasurable fraction of our global emissions. We're talking about a number so small it's hard to even wrap your head around. So, case closed, right? Rockets are fine. Well, not so fast.
And just to give you some scale here, commercial airplanes, they pump out over 900 million tons of CO2 a year. Rockets, less than 23,000 tons. In the grand scheme of things, it's like someone said, it's like worrying about a single leaf in a raging forest fire. But here's the twist, and this is the whole point. CO2 isn't the real story. Because here's the key. The problem with rockets has almost nothing to do with the amount of pollution. It's all about where that pollution gets dumped. Rockets are the only thing we do that directly injects exhaust fumes into the highest, most fragile layers of our atmosphere. And up there, the rules are completely different.
We're talking about the stratosphere. See, way up there, there's no rain, there's no weather to wash pollutants out of the air, so any chemicals that get shot up there can just hang out for years. In fact, they can stick around for up to 100 times longer than the same pollution would down here at ground level. And this is where the real damage starts to happen.
So let's forget about CO2 for a minute. These are the real troublemakers. You got black carbon, basically soot, from kerosene-fueled rockets, and it's a super potent warming agent in the stratosphere. Then there's chlorine and alumina from solid rocket boosters, which are just brutal on our ozone layer. And then, get this, nitrogen oxides, which are produced by all rockets on the way up and, believe it or not, on the way back down when they re-enter the atmosphere. And they damage the ozone too.
And if you want to know just how potent this stuff is, well, this quote from the research says it all. The climate warming power, or efficiency, of black carbon is way, way stronger when it's released up high. A tiny bit of soot in the wrong place can do an incredible amount of damage.
500 times. Let that just sink in for a second. What that means is that 1 single gram of soot from a rocket in the stratosphere has the same warming impact as 500 grams of soot from a factory or a plane down here. It's an issue of extreme leverage.
And this chart, it shows you exactly what that leverage looks like. Rockets produce a tiny, tiny fraction of the world's black carbon, just 0.02%. But that minuscule amount may be responsible for a whopping 6% of the total warming that comes from soot. It is the classic definition of a small source having a giant outsized impact, all because of location, location, location.
And the problem isn't just about warming either. New research is showing our ozone layer is actually getting hit from 2 different directions. You've got the chlorine from solid rocket boosters during the launch, which we've known about for a while. But the really surprising part is that the nitrogen oxides created when reusable stages or old satellites burn up on re-entry, well, they're just as damaging. It's a real 1-2 punch to the planet's sunscreen.
Okay, so that is a lot of bad news. I get it. But it's not all doom and gloom here. The industry is changing, and believe it or not, there's actually a pretty clear path to launching rockets more cleanly and fixing a lot of this damage.
A huge piece of the puzzle is just the fuel itself. The industry is already starting to shift away from these dirty, old-school fuels, like the solid boosters packed with chlorine and the super sooty kerosene, and they're moving toward cleaner, next-gen options. Methane is a big step in the right direction, and hydrogen, well, that's kind of the holy grail. Its only exhaust is water. So the path forward isn't some big secret. It's actually a pretty clear 3-step plan. First, phase out those dirty, solid rocket boosters. Second, move faster on adopting cleaner fuels, like methane and hydrogen. And third, make reusability the absolute industry standard, because that slashes the massive environmental cost of having to build a brand new rocket for every single launch.
All right, let's tie this all together.
What's the final takeaway? Are rockets wrecking the planet? The answer is complicated. It's not so much a problem of today, but a problem of scale and what could happen tomorrow.
So here's the core tension, right? The good news is that right now, the CO2 impact from rockets is a total drop in the ocean. It's negligible. But the bad news is that the pollutants that really matter, the soot, the chlorine, the nitrogen oxides, they have this ridiculously oversized effect way up in the stratosphere. And the catch? The industry is growing exponentially. We're launching more than ever. So the ultimate risk is that just a decade of, say, space tourism could seriously undermine decades of incredible progress we've made healing the ozone layer.
Which leaves us with this final question. As we keep pushing farther out, reaching for the stars, how do we make sure we don't wreck the very sky that holds them? The challenge isn't to stop reaching, it's to reach more responsibly. How do we innovate our way into the cosmos without sacrificing the very atmosphere that makes all of this possible in the first place?